Welcome to Huawei eLearning service. My name is Thomas Rechenbach, and today I will talk about the LTE air interface. LTE air interface is about, it's divided into 4 chapters. First, the air interface itself. Then we go into the general principles of the air interface. The third part is about dynamic resource allocation. And finally, we talk about the mobility in LTE. So what's about LTE, the air interface? First, have a look at the development, the history of evolution of mobile networks. Then the next part will be about the 3GPP releases. Then we talk about the radio interface technologies which are used. The next is about the transmission modes. Chapter 5 is about the spectrum usage. And then the channel coding in LTE will be discussed. And finally, we come at the heart of LTE is a new modulation technique which is called OFDM. So now let's have a look at the evolution of cellular networks. We have different generations of mobile phone networks. It all begins with the first generation of mobile networks, which are analog and are very diverse. So different types of networks were developed with low capacity and with almost no features, just for voice calls. Then the first digital generation of mobile phone networks was the second generation. The most important one was GSM, which has a widespread use all over the world. Then we have the third generation, which has a focus also on data. So voice is important as well, but it's important also for data services. And we have now in service the fourth generation, and one main part is about LTE. And also already in the development is the fifth generation, which is not shown here. So let's start with the first generation of mobile systems. There are a variety of systems which were in use, depending on the developing countries. So one important country was America, the US. They developed the advanced mobile telephone system. In other parts of the world, we have the Total Access Communication System, TACS, and further development of this TACS system is the extended TACS. So the second generation of mobile systems, the most important point is that the systems are digital and not analog anymore. We have different types of second generation mobile networks. The most important one is GSM, Global System for Mobile Communication, which was developed in Europe but has a widespread use and is still used all over the world, and it will be used in the next years to come also, that's for sure. Also, America is an important player in the development of digital mobile systems. They have a further development of the AMPS system, which is the analog one, but now it's the DAMPS system, and D stands for digital. It's developed under the interim standard 136. Then DAMPS uses time division multiple access scheme, as well as GSM, and the code division multiple access scheme is also used in the second generation, and this system is called CDMA1. It's developed or described under the interim standard 95. There are also some other digital second generation mobile systems. For example, in Japan was a Japanese standard personal digital system, PDS system. Yeah. So let's focus on the most important second generation mobile system, which is GSM. GSM was enhanced in several steps to add, it was added the data service, or was improved. In the first version of GSM, we only have circuit switched data service, so a fixed capacity and a fixed data rate is offered in the first version with a very low data rate of 9.6 kilobit per second or 40.4 kilobit per second. You see here, this is the theoretical data rate, but in practice, we have also the same data rate. But when we go ahead to GPS, which was the first improvement, first evolvement of GSM, introducing the packet-switched data service with not fixed, with variable data rates, and the theoretical peak data rate is about 170 kilobit per second. But in practice, because of transmission errors, radio link distortion, we have in practice data rates between about 4 kilobit per second and about 50 kilobit per second. This system, GPS, was also evolved to Edge, which is an enhanced GPRS data service. The modulation was changed from bit binary phase shift keying to 8 phase shift keying, so offering 3 bits instead of 1 bit to be transmitted in one symbol. So consequently, the data rate is 3 times higher than for GPS service. In theory and in practice, we can achieve data rates up to 120 kilobits per second. So the focus of the second generation was on voice, but it was also offering some basic packet switched services, data services. And in the third generation, one important focus is on the development of the packet switched service, so with the higher data rates and yeah, more important service can be offered. The most important third generation system was wideband code division multiple access, YCDMA, which is better known as UMTS, Universal Mobile Telecommunication System. YCDMA is using a code division multiple access scheme on a wide channel, so it's a widespread spectrum. It uses 5 megahertz bandwidth. UMTS has different subtypes. So the main is UMTS itself. This is frequency division duplex. This means we have one frequency, separate frequency for the downlink and another frequency used for the uplink. There are two TDD versions of UMTS. TDD means time division duplex, using the same frequency channel for the downlink as well as for the uplink. TD-CDMA is the system developed by 3GPP standardization organization, and TD-SCDMA was developed in China together with important players like Siemens for the Chinese market. And TD-SCDMA stands for Time Division Synchronous Code Division Multiple Access. It uses smaller bandwidths like UMTS, and synchronized stands for that the uplink needs to be synchronized between the different users using timing advance mechanism, which is already known by GSM because it also uses time division multiple access like GSM, but together with code division multiple access. Then in America we have CDMA 2000, which uses a smaller bandwidth like UMTS. It uses in the first 3.75 megahertz, and it's only used on the American market. And then we have finally WiMAX, which was developed by IEEE in the United States. First, it was developed for point-to-point communication, and for point-to-multipoint communication, so using fixed transmitters and fixed receivers, and then to be part of the third generation of mobile systems, it added features for mobility of users. Yeah. Then let's come to the fourth generation, which is in widespread use already. The requirements for fourth generation mobile systems were developed by the International Telecommunication Union under the project which is called IMT, International Mobile Technology. The ITU set up also the requirements for the third generation, and this was called IMT 2000. For the fourth generation, the requirements are under the title of IMT Advanced. And the requirements are as follows: a high degree of commonality or functionality worldwide, meaning that we have several functions which are available, which can be used throughout the world, but which are flexible to be modified, activated, deactivated in different parts of the world as needed. Then support for a wide range of services like voice service, data service, different types of data service, video telephony, multimedia communication, and so on. The services have to be compatible with all other IMT technologies, as well as with fixed line networks, so that the fourth generation mobile system can be connected to every other IMT system and to fixed telecommunication systems. Then an interworking with existing mobile technologies should be possible. So, for example, handover between a fourth generation network and a third generation network and a second generation network, and so on. Then high quality services should be provided. This means there should be quality of service mechanisms in the network to guarantee certain bit rates, certain error rates. User equipment should be usable worldwide. So this is about the compatibility of the user equipment with the network, as well as worldwide roaming capability. This has to be seen together. Compatibility, roaming, and compatibility of the handsets. The services and applications should be user-friendly. And one of the important points is about the data rate. This is the last point here. In low mobility environment, the fourth generation should offer data rates up to at least 1 gigabit per second, and in high mobility state up to 100 megabit per second at least. So the fourth generation requirements are fulfilled by different standards. The most important one is LTE Advanced, which is backward compatible to LTE, and a further development using higher spectrum bandwidths and higher modulation schemes, offering data rates up to the required 1 gigabit per second and also higher. Also, WiMAX is developed to fulfill the requirements of the fourth generation mobile system. And finally, we have also the UMB standard, which is a further development of CDMA 2000, which is a third generation mobile system used in America. Thank you for watching.